The universe appears to be infinite, but starting from the tiny dot of the Milky Way, humans are ready to conquest infinity. After many successful space missions, we are now very close to venture the space personally, beyond our own solar system.
Put together, it's a new window into the history of our universe. And today we're going to get a glimpse of the first light to shine through that window.
The only way to know about space beyond our solar system is electromagnetic radiation. We as human beings receive all our knowledge through our eyes. But we can see only a portion of the visible spectrum. If we could see into other wavelengths, then the invisible light can tell us more about the mysteries of the universe. The idea of building a massive space telescope came into existence to look deeper into space and study nearby clouds of dust, which leads to the formation of stars and the earliest planets. Our atmosphere, which protects life on Earth, absorbs the starlight in this portion of the spectrum. The space telescopes are therefore designed and developed to study the universe from hundreds of miles out in space. The space telescopes are placed above the blotter of air that absorbs the ultraviolet ray, X-rays, and gamma rays. The first space telescope orbiting Astronomical Observatory 2 was launched by NASA in the year 1968. The telescope was launched to an orbit of 750 kilometers from the Earth with the Atlas Centaur rocket, which was initially developed for sending Surveyor spacecraft on its mission to land on the Moon in the early stages of the Apollo program. OAO2 provided us the first orbital stellar observations in ultraviolet light, which are shorter than the wavelength in the visible range spanning from 3,800 to 7,500 angstroms, which are screened out by the atmosphere and unavailable to ground-based telescopes. The OAO2 was the biggest and most complex unmanned satellite in the NASA program, which remained in operation until January 1973.
This satellite, the OAO, is the biggest and most complex unmanned satellite in the NASA program. When it has been placed in an orbit 500 miles beyond the Earth, this space observatory will give us eyes to see into regions until now invisible to man.
The OAO2 telescope opened a new window to the universe. Later, in 1990, the Hubble telescope was launched into the lower orbit of the Earth. The telescope discovered many objects previously thought to be clouds of dust and gas, and they are classified as nebulae. These nebulae were actually galaxies beyond our Milky Way galaxy. The Hubble telescope was placed in lower Earth orbit at a distance of 547 kilometers from the Earth's surface. But this video isn't about the OAO2 or the Hubble's telescope. This video is about the James Webb Telescope, which is recently launched into space by NASA, and images sent back by this telescope are absolutely from another universe.
And we have engine start. And liftoff. Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe.
NASA's James Webb Telescope is a space telescope that is primarily designed to conduct astronomy research with infrared signals. The telescope is placed in L2 orbit, which is around 1.5 million kilometers away from the Earth. James Webb Telescope is placed in this orbit to see what the universe looked like around 250 million years after the Big Bang, when the first stars and galaxies started to form. Scientists think that the James Webb Telescope will be a giant leap forward in our quest to understand the universe and our origins. The Webb Telescope will examine every phase of cosmic history, from the first luminous glows after the Big Bang to the formation of galaxies, stars, and planets. It will also help scientists to study the evolution of our own solar system. The construction process of the telescope took 25 years of a long time due to the sheer complexity of the unit itself. Researchers in the development team put all their efforts to ensure everything is perfect before the launch. The mirror segments of the telescope are made of beryllium and then they are coated in gold. Each mirror weighs around 20 kilograms on Earth. The total weight of the telescope is approximately 6,200 kilograms. The size of the sun shield of the telescope, which is used to keep the telescope cool, is about 22 meters by 12 meters, which is half as big as a Boeing 737 aircraft. Therefore, the telescope was folded into a small unit to launch it into its orbit. The James Webb Space Telescope was launched on an Ariane 5 rocket, which was a part of the European Space Agency contribution to the mission. The next step for the telescope was to unfold itself in space and align the 18 individual mirrors that make up the observatory's primary mirror. The process of unfolding and alignment of the mirror took approximately 120 days after the launch of the telescope. The new images sent by the James Webb Telescope are very clearer than the images we have earlier. The new unprecedented look of the deepest space is a stunning improvement over similar images taken by its predecessor, the Hubble Space Telescope. With a total cost involvement of $12.5 billion, the James Webb Telescope is the most powerful and expensive space science telescope that NASA has ever launched into space. The Webb space mission was initially projected to be at least 5.5 years. However, after the successful launch of the telescope, NASA found that the observatory will have enough propellant fuel to support scientific operations for more than 10 years. The telescope collects infrared light to enable us to see the most distant galaxies, which we can't see through other surface telescopes. It is composed of 18 hexagonal segments, each of which is individually tunable to provide a precise focus on the universe. The Webb has 4 separate cameras to perform its scientific operations. The first photo from the James Webb Telescope, which has recently been released by NASA, was taken by the NIRCam on board the telescope. NIRCam means Near Infrared Camera, and it is the first of its kind most sensitive camera ever built to observe the universe. The Webb is primarily an infrared telescope, so it sees lights in a longer wavelength than what we see with naked eyes. Besides NIRCam, some other scientific instruments are also installed in the James Webb Telescope to perform different operations. These instruments are Mid-Infrared Instrument or MIRI, Near-Infrared Spectrograph or NIRSpec, Near-Infrared Imager and Slitless Spectrograph, and Fine Guidance Sensor NIRI SSFGS. The telescope is specially designed and developed for detecting near-infrared and mid-infrared wavelengths, that the light beyond the red end of the visible spectrum. The telescope will certainly open a window to study the universe, and hopefully it will be a great achievement to explore distant stars and galaxies. Hope the video was informative. Thanks for watching. Subscribe to the channel and press the bell icon for more related videos.